Okay, I've had some food and I feel good. Had some food and feeling good. Okay. Hey Jesse, have you woken from your slumber? This thing brings back some memories. Yeah, this brings back some good memories. Is Amplifier repairing your job? Yes, it is my job. Greetings from the US, how's it going? Thanks for sharing your craft. No problem, buddy, no problem at all. This amp does bring back some good memories because this is one of the first amplifiers that I ever really used in my own vehicle many years ago. This could be quite an interesting one and hopefully not a very complicated one. Okay, so let's have a look at this then. So, this is a loudest.com TL-1021. This is the 3000 watt RMS at 2 ohm amplifier. This is basically just two ICE 1500 boards internally bridged. It is a 2-channel amplifier because it's two monos. Well, it's a dual mono essentially. This is a dual mono amplifier. Just sharing power inputs over here. And the customer said that this amplifier stopped working and it started smoking. So if it starts smoking, usually the smoking is because the power supply section has failed. However, in this amplifier, we don't have a failed power supply section. We have no continuity between the power inputs. So I was looking around the board. Now if something starts smoking, then obviously we're looking for some burnt areas. What I did notice was two very, very burnt areas over here. If this does to focus in. So this here is the case ground wire. So this is the piece of wire which is connecting the amplifier's heatsink case to ground. Now this has been properly smoked and obliterated, as we can see quite clearly here. There is another one over on this side of the board over here, which is connected to this small piece of wire over here. And this one as well, if I remove this small header, this one as well has also been very, very badly burnt. Now, the only reason that these wires would get burnt is if the case itself has some high voltage on it that it shouldn't have, and it grounds the high voltage, therefore basically the wire acts like a bit of a fuse. So I was going ahead and probing the amplifier with my multimeter here, and I noticed that there seems to be continuity between the case. If I put my black probe in one of the case screw holes here to get the case, there appeared to be continuity between some of the rectifiers and the case, which is really unusual. So why would there be continuity between the rectifier and the case? Now, the only reason that there'd be continuity between the rectifier and the case is if these thermal pads have got a hole in them and therefore are basically transferring the voltage from the rectifier themselves to the heatsink. You see there, this thermal pad could have a hole in it, or this one looks a bit skew-whiff to the side. Look, see, that looks a bit skew-whiff to the side, so I wonder whether that's actually touching the screw maybe. So it appears that the amplifier has gone down because of a poor build quality, and actually, yeah, that's what's caused the issue. There's no shorted output FETs, there's no shorted power supply FETs, there's just continuity between diodes and case. So that means that there should also be continuity between the amplifier's main ground over here on this side of the board and the diode, which there is. So the diodes are shorted to ground. So what I'm going to do is I'm actually going to remove the case ground wires and see whether the short goes away. Because if the short goes away to case, then that's what the issue was. It was just shorting to the case somehow. Let's see. So case. Aha! Okay, so now that I've removed the case ground wire over here, the short circuit to case has gone away. It's no longer on the diodes. So that proves to me that there is in fact a short circuit between the diodes, the rectifier diodes, and the case. So what I need to do is to confirm that. This is a very interesting repair actually. I'm going to reconnect the case to the ground. Okay, just temporarily. I'm just going to reconnect the case ground to the amplifier over here, the one that got burnt badly. And then we should have the continuity to ground again, which we do. Okay. Then what I'm going to do is I'm going to start unscrewing the clamps for the diodes. So I'm going to start off with this one here. And we're just going to lift these diodes away off of the thermal pad. 1, 2, 3. And we're going to see if the short circuit goes away. Okay, no, it's still there. So it wasn't these 3. Let's try the next 3. One, 2, 3. Let's see if the continuity's gone away. Nope, still there. So then we try these 3 on the second board over here. One, 2, 3. No, it's still there. So therefore, by process of elimination, it might be these ones. Now, if removing these last clamps for these rectifiers doesn't get rid of our short, then the issue is likely on the underside of the boards, and they are touching the case on the back of the boards because the leads haven't been cut short enough. So let's see, has removing those ones got rid of our short? 1, 2, 3. Okay, no it hasn't. So there is still a short between the rectifiers and the case. So we need to take the boards out of the heatsink and have a look on the underside of the boards to find out where the connection is between the rectifiers and the case. The actual amplifier itself seems to be fine. And I can probably prove that by removing this. Actually, I'm not sure I want to do that. Let's say removing this ground case wire and powering that board up, and it will probably work fine. But I don't want to risk it in case multiple things are connected together through the case. It'll just blow. So let's start the lengthy process of unscrewing all these screws and taking both these boards out of the heatsink. Now, does anyone want to hazard a guess as to what these amplifiers actually bench power-wise? So they are rated at 3000 watts RMS at 2 ohms. What do you think these amplifiers bench? Larry Price gets it pretty much spot on. That's about what these amplifiers are supposed to bench. So once we finish this repair, we'll be able to find out. Actually, Larry Price is slightly wrong. It's a 2 ohm amplifier. So this amplifier is not 1 ohm stable. Mono, it's only 2 ohm stable mono. But yeah, it's meant to do about 2.2, 2.3k at 2 ohms, 14.4. Adam Francis, 2.7k at 2 ohm. Maybe. This is one of the slightly newer ones, so it might do. Indeed. Indeed, my friend. Yeah, guys, if you're interested in watching some hilarious build videos of car audio builds and the problems that you encounter during car audio builds, click on Adam Francis in the live chat and check out his channel. He's got some very, very funny videos of his build progress. He's got some really funny content on there, and he's a good character, so check that out. God damn, this is a lot of flipping heatsink clamps. Give me a shout when you touch the 1K I gave you. Which was the 1K you gave me? I can't remember. Oh, the loudest.com one. Yes. Yes, of course. Yes, I will do. I will do. Yeah, this takes fucking ages. Come on, man. Alright, we've got one left. One of these stank ass clamps left to do. And then we just got to remove the front, both side plates. Actually, I haven't got to remove both side plates. I've only got to remove one side plate and one end screw. One RCA screw, and then I just need to remove this side plate, and then it should come out the heatsink. Right, that should be good to go. So now, if I start lifting her up, you should get all those things coming off, like these. Okay, that's the first board. I hate these boards where there's like two boards conjoined together. Not nice to work on. There we go. There we go. Okay, well I don't see any obvious shorting to the heatsink from the metal on the back here. Let's have a look at the back of the boards here. So something was definitely shorting to the heatsink, and it should be fairly obvious what it was, because it would have got hot usually. Interesting. Oh mate, wait, maybe I can see. Maybe I can see it. Huh. It doesn't seem to be that obvious. Okay, well let's get the heatsink out of here. Let's just put this down to one side. God damn it. Okay, so we had a short circuit between heatsink ground and rectifier, which we still have, but that might be intentional because that actually might be a virtual ground for the output section. So what I'm going to do is I'm actually just going to try and power the board up outside of the heatsink like this. It could be that I don't know, the customer touched the positive on the case ground, maybe? So there doesn't appear to be anything blown on the amplifier. So what I'm going to do is I'm going to take my power supply wires here. And I'm just going to try and give her some power and see what it does. Okay, power wires are in. Turn the power supply on. Go up to about 10 volts. What are you fusing this power at? Sorry, buddy. Scott, what do you mean? What am I fusing this power at? Okay, so let's apply some power and see what it does. Huh. Okay. It comes on. Both boards appear to be working. Let's check for output switch. We're drawing 1.6 amps and output switching waves look good on both boards. We have a blue light. Ah. So the amp itself works just fine. Doesn't appear to be any issues here, guys. Yep. Good. Good switching waves. Yeah. Okay, so the amp itself works fine. So there must have just been a short to heatsink. So what I'm going to do is I'm going to put this back together very carefully, making sure I watch out for any holes in this thermal pad. If I see any holes or anything, then what I'm going to do is I'm going to replace the thermal pad in that area. And also I'm going to obviously replace this heatsink ground cable with something. What are you limiting it to? So my current limiting is all done by my adjustable power supply here. So I can push this button, it tells me what my maximum volts available are at this current, so 18 volts at this current. Well, just then I was actually allowing 20 amps to pass, but that was a mistake. I was I was actually supposed to only be allowing, I'll turn this down a little bit. I was going to allow about 2 amps, so I can adjust how many amps I let pass to the amplifier at any time. So small amplifiers, generally I leave it between 1.5 and 2 amps. Slightly larger amplifiers, I'll allow 4 amps. And really big amplifiers like 10,000 watt jobbies, I'll apply anywhere between 6 and 8 amps to power up. So let's wait for these rail voltages to sink back down. From memory, I don't think these amplifiers have pull down resistors. No, they don't. So I'm going to have to short out the rail caps manually. There we go. That's all the rail caps shorted out, so there shouldn't be any voltage left on the board now. Let's get the heatsink back and put it back in the case, and yeah, go from there, I guess. Evening Lee. Yeah, I will bench test this once we finish the repair just now. Shouldn't take too long. Just needs a new case ground wire and reassembling, and I think it's going to be just fine. Sam says it is a shorted fuse. Now, can anybody tell me why the term shorted fuse makes no sense whatsoever? Okay, so let's start screwing this back together and do a bench test. Yeah, boy! Bench tests are fun. I tested it for a short before screwing all those back together. Yeah, well, I didn't see any shorts in the thermal pads, and I just powered it up before. I just powered it up out of the heatsink. So I've got to start screwing some of these down to look for a short anyway, because it's not visible by the naked eye. So if there is a short, then it'll only present itself when these are screwed down and power is applied. What are you going to use for the new case ground? I'll use some cable that I have spare, and I'll solder it to the original ring terminal from the original case ground that still remains, that survived. So I'll yeah, cut the ring terminal off, solder some new spare cable to it, and it'll be good in the hood. The nice thing about these amplifiers is actually the circuit design in these is actually quite efficient. It's not a bad modern circuit design. It's very basic, it's very generic, but it is pretty efficient, and they run rather cool. They don't get very hot, these circuit designs, and as a result, with this amplifier, although it has two of these amps inside, the heatsink is so large that actually the heat dissipation is rather good, and these don't really get hot. Is that a power drill? No, is that a power drill without power? No, no, no. This is a multi-barrel screwdriver, so I can like change the tip end for different types depending on what I'm doing. Yeah, pretty useful. The reason that I don't use a power drill when I'm doing these up is because you need to be able to feel with your hands and your body, you need to be able to feel the thread, and because on these clamps, if you accidentally de-thread them, if you screw it up too hard and you lose the thread, it becomes absolute nightmare to redo it, because, well, anyway, these need a decent pressure to be clamped down onto the heatsink. If they're not clamped down with good enough pressure, then the heat won't transfer properly and you'll end up with a blown amplifier. So you have to make sure that you screw down with a good pressure and a good tightness, good amount of torque, but you want to be able to feel when the aluminium, because aluminium is made of fucking cheese, you need to be able to feel when the aluminium is giving way, and therefore stop yourself from breaking the threads. So, show of hands, who's going to Modified Nationals this year? Obviously only if you live in the UK, that's relevant too. Are those transformers secured down? No, these transformers are not secured down very well at all. These are just floating around. I mean, actually, they've been wound incredibly tightly, so they are not wobbly in the slightest. They're actually very, very secure, but they are not like secured with any silicone or anything like that. The inductors are actually seated quite well with some silicone. So in terms of build quality, it's not too bad on these. Not the worst. I've definitely seen worse. That Phoenix Gold was much worse. The brand of amplifier is in the video title, the loudest.com. Loudest.com this is. Loudest.com TL-1021. Yeah, there's a fucking shit ton of clamps. It's really annoying. And they're all done in pairs as well. I'd prefer it if they were like in fours or something. But stay with me. Once we've done all the clamps, we're going to bench test it and see what power these make. Was the case ground you removed insulated? It looks burnt up. Yeah, so the case ground was super burnt up, and that's why the customer thought the amp was blown. I reckon he's touched his 12 volts power wire on the amplifier case. How much do you charge for a repair like this? Well, if I'm being perfectly honest, this repair wasn't really a lot to do. Hang on a minute. That's fucking. This repair seemed to just be like the customer thought the amp was blown because he touched his case grounds. He touched his power wire to the case, which grounded the case ground wires and caused a lot of smoke. So he thought it was blown, but actually the amplifier doesn't appear to have any faults as such. So for this, I'd probably just charge 25 or 30 quid just for the massive health checks that I'm going to be doing, and also going to secure down the transformers a bit better, things like that. So it's just a general service on this one. It's not even going to fucking go. How do you charge people? Is it by the hour, or the same cost all the time? No. It's not by the hour as such, but it is related to how long the repair takes, how much the parts cost, and how much of a headache it is, and the complexity of it, etc., etc. So yeah, it's not exactly an hourly rate that I charge. It is dependent on a few different factors: parts cost, research time, obviously time spent doing the repair, complexity of the repair, what tools were needed to complete the repair, what pieces of equipment, etc. Hey, I just tuned in. Love your amp repairs. What was wrong with that beast of an amp? Nothing was actually wrong with it. The customer, I reckon, has touched the his power wire to the amplifier's case, which causes the huge amounts of current to go through the case ground wires, which is this, and it just basically grounds out the 12 volts, and it causes a lot of smoke. This burns up and smoke comes out the amplifier, and so it looks to the customer like the amplifier is blowing because there's smoke pouring out, and his voltage is probably dropping like crazy. So, but actually doesn't appear to be anything wrong with the amplifier itself. How much per curse word? Yeah, I like that, yeah. It depends how many times I say stank. Like, it's how much per stank. If I say stank a lot, then it's usually a really expensive repair. Is the big red wires for speaker output or power? The big red wires, well, so these two here, these are the power wires. So this is just two amplifiers in the same case. So obviously the first amplifier gets its power from the terminals over here. The second amplifier, this one, obviously gets its power from these two power cables that are running to this board. These wires here, these big ones, these are the speaker outputs. So yes, the speaker terminal outputs from this board go over here to the terminals, and the same with this one, go over here to the terminals. And then there's a shared ground wire between the two boards as well. think this. I think we'll see about 2,350 watts RMS at 2 ohms. Yeah. Technically, this amplifier should clamp some really fucking big power, because look at all these fucking clamps! Okay, so just quickly now, I need to replace the case ground wire. You guys are guessing some pretty big power ratings from this thing. I don't. This isn't going to do that much power, you know, guys. It's not a massively great amplifier. I love the Virgil Dante's comment. That's funny. Look, I'll tease him. Virgil Dante, I'll tease him. Look at this. Oh. Oh yeah, that feels good. Oh yeah, just snip this one here. Oh yeah, yeah. Yeah. That's good. If I cut these wires by accident, like this one here, no big deal. I just strip the cable and solder it back together again. Can we see what voltage it protects at, please? Says Adam Francis. Yeah, but my power supply only goes up to 16 volts, and I don't think it will protect at 16. I've got a funny feeling these things you can run up to about 18, and I don't think I can give it 18. I might be able to. We'll have a look. Adam, it's not going to beat your B2, no. Don't you worry, my little friend. This is not going to beat your B2. I think B2 gear is superb build quality. I love B2 amplifiers, I love B2 subwoofers. I think their innovation and their attention to detail is very, very, very good. Some of their amplifiers appear to be a little bit overrated though, but the build quality is superb. And they're a good price for what they are. They're not cheap, but they are very good amplifiers. The subs are really good as well, very musical, drop low, take loads of power, etc. Really, really good. Okay, so that's both case ground wires repaired. And now it's time to flip over and do a bench test. Before we do a bench test, let's just do this. I always do this after I've finished repairing an amplifier, just to get all the crap out of it. all the, you know, in case any bits of solder flew in there, and also because, you know, it's like Lion King, like I just finished this fucking repair. Repaired amplifier. So let's see, does it make its rated power or nah? Reese, my friend, this is your amplifier, isn't it? Is this your amplifier, Reese? The repair? The one that you gave me? Okay. Oh, that transformer makes a horrifically loud buzzing noise at a certain voltage. So Adam Francis wanted to know what voltage this goes into protection at. So I'm just gently cranking the voltage up. We're going to try and hit, what do we do? Is try and hit 16 point... Yeah, let's do... Let's do 16.3 volts. So you can see here on my thing, we've got 16.3 volts in there. So will this amplifier turn on with... Just start down at 15.2, just quick. Slowly take her up. So it runs at 16.3 volts and doesn't protect, so cool. That's as high as I can go, unfortunately, guys. Right, okay, so let's plug in the big power supplies and see what it does, see what power it makes. I thought this thing was 18 volts as well. I reckon this will go up to 18 volts. Hello, is it going well? Yes, my friend, going very well indeed. And Reese Gibbs, you've just tuned in, haven't you? So you haven't seen the repair log of this. So, yeah, basically, Reese Gibbs. Where's it gone? Yes, Reese Gibbs, this amplifier was an absolute mess. Oh my god, the whole thing was completely obliterated inside. Basically had to completely rebuild it from the scratch, from the ground up. Absolute massive headache, nightmare of an amplifier. It's going to cost you an absolute fortune. I'm really sorry. What is your fee to let Tim watch while you fix it? Nothing, man. I don't charge people to watch it while I fix it. Yeah, I'll calculate it for 18 volts just to see. It does sound like some kind of weird fetish, doesn't it? Right, so Reese, where the bloody hell are the grub screws, man? You didn't include the grub screws. Damn. So I can't screw in my dummy loads. I have to replace them. Let's see if I've got some spares. I don't know if I've got any the right size, you know. Let's have a look. You're lucky, it's my last two grub screws for this. And because I'm running it in bridge mode, I only need 2. So I'll give you 2 extra grub screws, but they'll be small ones for the middle 2 grounds that you won't really ever use. Just so that they're there. Right, okay then. So this is a 2 ohm amplifier, so I only need to use 2 of my dummy loads. We wire down to 2 ohm. We're going to bridge it. Unfortunately, Bridget couldn't be here with us today. She had a pretty busy schedule. So in her honour, we're going to bridge it. Hammer Knock says it's mono. Nope, it's not mono. This is not a mono amplifier. This is a twin mono, aka 2-channel. It's not a true 2-channel because a true 2-channel amplifier shares a common power supply. This amplifier is 2 mono amplifiers in the same heatsink, making it, by a correct term, a twin mono. Therefore, you have to bridge it to get a mono style output from it. What does it do at 1 ohm each channel? It's supposed to do 1500 watts at 1 ohm per channel. Who the fuck is Bridget? Ah, I don't think Henrik got the joke. Hammer Knock says 2 wires only go to the speaker outputs. No, my friend, 4 wires go to the speaker outputs, but the speaker outputs are already on one board. So if you think about it, you have one board here and you have a second board here. This is your first channel, this is your second channel. The speaker terminals are connected to the first board, so therefore there's no wires that need to go to that speaker terminal because it's connected to the board itself. The only wires need to come from the second channel because it needs to go over the first channel to the speaker terminals which are on the other board. Trust me, I know, I owned one of these for like 4 years. It's a two channel. You can listen to stereo speakers using this. And because it is a stereo amplifier, I need to use both RCA inputs, so I need a splitter. Hammer Knock says so it's bridged already or strapped. It's internal. No, it's not. It's not bridged or anything like that. It's just a normal stereo amplifier. It's just a normal 2-channel amplifier that you can bridge because one of the speaker outputs is out of phase with the other one. So when you wire it normally, the speakers both are in phase because one channel's flipped, and then when you wire it in bridge mode, it works automatically because the other one channel's flipped already, so it's 180 degree out of phase, so they work together. Easy, easy, normal. Okay. So we're going to test at 45 Hertz. Okay, yep, I was just confirming both channels were working, so now let's plug the dummy loads back in properly. And in order to show you guys that this is in fact a 2-channel amplifier that is working together in bridge mode, I'm going to use both of my oscilloscope probes on each of the channels, and you shall see that the 2 waves ride out of phase with each other. And then we'll use some channel math on my oscilloscope to combine the 2 waves to show you what the resulting wave to the subwoofer ends up looking like. So, channel 2, activate, channel math, 1 minus 2. 50 volts divide, I think. No, screw it, 20 volts divide. It's a very dirty looking output, I'll give it that. It's a very dirty looking output. Okay, there we go, we've got some clipping going on there. Okay, so the waves are quite clipped there actually. I'm probably going to do that again. And to turn the gain down a touch. One channel actually clips earlier than the other. Can you see that? So you've got the two amplifier boards inside this case. One of these is clipping a little bit earlier than the other one. Oh, and you can see that the two voltages here, they're about 0.8 of a volt off each other. Okay, that'll do. So what I'm going to do is I'm going to take 30.84 as the clip level for that, because if both channels were perfectly matched, then they would both be 30.84. The reason that the channels are not perfectly matched is because this is a very cheap amplifier with very cheap internals, and so both preamplifier boards are not exactly the same in terms of gain of the sine wave. So therefore we end up with a very slightly different output from each channel. Only very slightly. I've seen far worse than this. This isn't too bad. I've seen amplifiers that are way further off than this. Okay, and I forgot to check the voltage drop. What was the voltage drop that we saw there? Let's put one of my probes on the positive power input here. Let's just do the test one more time and measure the voltage drop. Oops. It was 11.87. 11.87. Okay. Reese Gibbs says this amp or keep the 1.4. They're very different because the 1.4 is a 1 ohm amplifier and this is a 2 ohm amplifier. So they're you know, it's not one or the other really. You use both of them for different purposes. Right, so how much power was that then? That was 30.84 times by 2 to give us our bridged output, which was 61.68 volts. So if we do, where are we? $61.68, and that was at 2 ohms. So at 11.87 it was 1902 watts RMS. If we correct that for our 14.4 volts, so 14.4 divided by 11.87 equals 1.213, square the results, give our correction factor, and times the correction factor by the power that we saw, 1902.2112 equals, oh, I was wrong. I was a little bit wrong. It did more power than I thought. 2, 7, 99.511 at 2 ohms. There you go. That's how much power it would do at 14.4 volts. Not bad at all. That's bang on 2,800 watts. Not bad at all. Pretty impressive. Yeah, that's very good value for money, you know. Very good value for money. Adam Francis did literally say 2.8k. Yeah. Okay, so Adam Francis then, my friend. What would this do at what? Should we see what it would do at 16 volts? So it's, what was it? 16 volts. So 16 volts. Let's do 16.8. 16.8 divided by, and we're going to do 14.4 equals square the result times by 2,800. No way. 1902. Holy fuck! Okay, so this is our 16.8 volt power rating. Okay. And if by some fucking miracle this amplifier worked at 18 volts, yeah, 18 volts, if by some miracle this amplifier worked at 18 volts, we would see a horrific 4,375 watts RMS at 18 volts. Dave says, here's for an update on your T-line doors. Oh, thank you very much, Dave, for the $5. Thank you, that's massively appreciated, dude. Thank you. My T-line doors are in the exact same state as they were in my last video. They have the black vinyl on, and nothing has been done since. So apologies, not my fault. I'm waiting for Mr. Harwood Acoustics to come and finish them. But, however, for all those of you who are waiting for some kind of audio-based update from me, I have a surprise for you, which I will do a video of over the next 2 weeks. Mr. Adam Francis already knows what the surprise is, as do a few other guys who have come and visited me this week. So yeah. Pretty good. Pretty good. And right, so bearing in mind, you can pick these amplifiers up in the UK for like £80. £80 for 2.8k at 2 ohms. You cannot go wrong. You cannot go wrong. So, Ben Gibbs, are you still there, my friend? Oh, sorry, Ben Gibbs? Sorry, I meant Reese Gibbs. Sorry, man. Fucking brains this evening. So, yes, the amplifier, Mr. Reese Gibbs, didn't have much wrong with it at all. What happened, Mr. Reese Gibbs, is your power wire on the power terminals here must have at some point touched the amplifier's case, because there were 12 volts was shot through the case ground wires and burnt them out, hence therefore the smoke that you saw. But the actual amplifier itself was absolutely fine, so there was no repair that I needed to do to the amplifier. All I did was just replace the ground wire, the case ground wires, and just did a general health check. But yeah, seems pretty good. I'm going to also just improve the rigidity of these transformers so that they don't vibrate off the board anytime soon. So I'm just going to apply some really good high quality silicone adhesive underneath these transformers so that they stay nice and planted to the board and themselves. Cool. Okay. So yeah, that's that one. Pretty good power, I have to say. Pretty good power. Did you ever find an amp suitable for your car? I know you mentioned trying to get something like a Genesis 8 channel. Yes, I do. I have a Genesis 8 channel. It's a dual twin mono, dual class A amplifier. So there's two class A stereo amplifiers on board, and there's two Genesis twin mono amplifiers class AB on board. So it's a fucking thing of beauty, and I can't wait to get it wired in. Never work on any Orion XTR amps. Not that I can recall. I'm not sure if I have worked on any of those before. If I do, I'll do a live. If I get one in, I'll do a live stream of one. Mate, now for sure, call me before you work on the 1K. I'm stoked. Should we give Adam a call on live? On live? I wonder what he's got to say. Should we? Maybe we should work on Adam's 1K next. How would you like that, dude? Adam, would you like me to work on your 1K next? Because I think that should be a pretty quick repair. And I'm feeling generous this evening. Bevids, if I was to send you my blown MTX board minus heatsink, with all the heavy bits desoldered in a baggie at the bottom of the box to reduce shipping weight, might it be worth it? Unlikely, no. The shipping is just stupidly horrific, regardless of, like, yeah, it's a bit of a nightmare. Don't desolder shit from the board either. If, like, yeah, remove the heatsink and send the board on its own. That might help out a little bit, but don't desolder anything. That just makes life complicated. But yeah, Tom, why don't you get me to help you repair it rather than sending it to me? it's possible that Tom maybe doesn't want to fork out for the decent soldering iron and the oscilloscope that's required, maybe. So that makes sense. Obviously, just better to send it somewhere. Dude, I've got my 20-year-old kid watching your vids. It's a better education than I can give him with my workload. Better than I... Oh, no, wicked, man. Magic Budgie. Thank you very much, man. That's kind words. Really, really nice of you, bud. I'm glad that he's... yeah, I'm glad that he's able to learn some stuff from what I do. Cool. Okay. So maybe we'll go and get Adam's 1K. Because I think that should be a pretty quick repair. And then we can charge him a fortune for it, because we're doing it express service on live. Can I inbox you about my Vibe Black Box Space Fires? Yes, Paul Wisdom, you can. Shoot me a message. Class A in a car in the summer, you're gonna roast. yeah, but I have very, very clever cooling ideas, and it's to do with the build being isobaric as well. I have good ideas for amplifier cooling, trust me. O-scope I still need. Sam's got to pay everybody who helps. He's going to be in pretty deep. No scope. Got me a 30-watt fright tool soldering iron and a roller flux core. Okay. Yeah, no worries. Right, let's move on and let's repair Adam Francis's loudest.com 1K, seeing as we're on a bit of a theme here with the loudest.com. So if I change my text to Adam's stank 1K. There we go. Good evening, buddy. Just want to know, if you don't have a scope, is there any other way to check the drive signal in an amplifier? Not really. I say this every time. It's almost impossible, really, to do a reliable amplifier repair without a scope. You can repair an amplifier without a scope, but you're riding on complete luck as to whether the drive wave survived or whether there's things that just happen to be okay that you don't need to look for. So you can repair an amplifier without a scope by changing all of the common to die things. So if you just go through and you change everything that usually dies, so you don't have to check things with a scope, you might be able to do a relatively decent job on amplifier repair. But the problem is that you can't check to make sure. So if the drive waves are slightly off shape because of something that's wrong, something that's leaking, the amp might work for a few weeks and then blow again, and then you're causing more damage that then is even harder to repair. So yeah, it becomes a bit of a nightmare without a scope. Okie dokie. I think this is Adam's loudest.com. Ooh, they come in a nice fucking case. None of this Korean Zenon bullshit cardboard box. This comes in a nice case. The loudest.com invoice for Charlotte Mitchell. Who's Charlotte Mitchell? This was purchased on the... Oh, it's got some addresses on here, so I better keep this away from the camera. This was purchased on the... How long ago was this bought? 2015 this was purchased. And oh, this is pretty cool. So this amplifier cost £113 brand new. So if this does anything over, if this amplifier benches anything over 1000 watts RMS, that's a good buy. That is a good value amplifier brand new. Warning: mount separately from any subwoofer enclosure, not on a sub box. Mount flat facing the sky. Mount with plenty of air. Install correctly using the correct gauging of cable. Do not use a power cap and read the manual. Fucking hell, loudest.com know what's up. I actually have a newfound respect for loudest.com. They know their shit. Don't mount to the box. Mount it flat. Mount it with airspace. Install using the correct gauge of cabling. Do not use a power cap. Read the manual. Spot on. Fair play. Okay. Oh no, sorry. The total including delivery was £140. £113 net, VAT, PayPal fee. Okay, so £140. So if this bench is 1,400 watts or more, that would be very, very good value. Mount facing the sky, yeah, that tickled me as well. Okay, yes, we've got the original loudest.com. Ah, this brings back memories. This was my first bass controller. From my videos of my loudest.com 3K in my car. Ah, the clicks. Pioneer TSW 3004 SPL is going. Yes, that is a fucking memories, man. Tactile memories right here. Okay. Owner's manual. Owner's manual. Who the fuck is Manuel? Manuel relay instructions. Okay, this is some bullshit. Ready? The TL-1023 amplifier has a durable, precision-engineered, robust, heavy-duty build that offers fantastic bass reproduction and maintains such clear bass reproduction at uncompromisingly high power levels. You know those adverts you get for Marks and Spencer's that are like, this is not just a roast chicken, this is a hand-plucked, gravy, self-basted fuckery of a chicken. No, this is a generic Chinese amplifier board that's been around since the fucking 90s that you've put your badge on. Stop chatting shit. Adam Francis says, I robbed her. Someone gave it to me for free. Ah, cool. So this is obviously a female bass head. And she, yeah. And it's got her flipping email address on it as well. I might email her. I might email her a link to this amplifier repair video. That'd probably be a bit of a what do you call it? Invading her personal space a bit, like to use her email address, but it'd be quite funny to just be like, yo, this is your amplifier. Mounting instructions. Never mount the amplifier on its side. Not sure I agree with that one. If it's been built with any half decent build quality, mounting it on its side is no problem. Like on a 90-degree vertical surface, it shouldn't be any problem at all. Yeah, okay. It says, if you do not have sufficient experience or the tools to carry out the installation, it is imperative that you seek the assistance of someone who does or have the amplifier professionally installed. Ah, shit. Ah, well, there we go. Oh, sorry, guys. I can't touch this now. I can't. No, I'm sorry, man. It's gonna have to go back in the box. Fucking no chance I can touch this. Sorry, man. Oh, who are we kidding? Who are we fucking kidding? All right. Okay. So, overall condition looks pretty superb. Does it stank? Doesn't stank. It smells like a new amplifier. So, Adam, did you try hook this up? What was actually wrong with it? Live comments. You're not going to slam. Slam? That's a fancy box. I robbed her. Someone gave it to me for free. I run all black series, blah, blah, blah. Would you be interested in keeping... Wait, I run all black T series Fosgate amps, contemplating a one-of-a-kind liquid cooling. Would you be interested? Yes, absolutely. Yeah, Dave Taylor, keep me in the loop about that. Sounds pretty cool. Always had same batch approach to power components, but didn't know you could run these boards out of the case. to test for temperature current balance before. Yeah, absolutely. These amplifiers, they're incredibly efficient. So it's different with a Class A amplifier or some very highly biased Class AB amplifiers. Running them outside of the heatsink for any longer than 10 seconds poses a risk to the components, because they get hot very quickly because they're passing current even on idle. But these Class D amplifiers, they're dumping like what, 0.8 amps on idle, and they have so many parallel components that they stay stone cold to the touch. And so yeah, you can power them up outside of the heatsink, provided you've got no load on the speaker terminals, and provided you've got no RC, provided you've got no load on the speaker terminals, you can power it up as much as you like outside of the heatsink, and it's no problems whatsoever. And you can, powering up outside of the heatsink is really good, because it means that you can easily check for any heating of the FETs that are in parallel to see that they're off balance or if they're leaking, or yeah, it just makes life a lot easier. Why not use a power cap? I don't need to answer that. You can use Google for that. Oh, okay. A few people are asking why not to use a power cap. So the reason that there's no point using a power, well, right. So there's a fucking hell. Maybe I should just do a separate video on this. If I go into one about power caps now, this is gonna take another fucking half an hour. So if you're interested in why power caps are not really of much use in today's day and age, then click the subscribe button to my channel and click the bell notification. I will do a video on power caps and why they are pretty useless these days in due course. Right, so what do we have in here then, baby? A very nice looking amplifier. Oops, that scrolled down quickly. Jesus Christ, the live chat is on fire tonight. I tore apart a big cat once. Yes, there's fuck all inside. There's nothing inside them. 1 Faraday ain't gonna do shit, exactly. American Legacy. Yeah, American Legacy. That's what I had, one of those. If you want to use power caps, the power caps that you want to use are these. These are super capacitors or ultra capacitors. Each capacitor, I think, is 2,300 farads. No, hang on a minute. Yeah, something crazy like that. And this is the type of capacitors that's going to help you out. An American Legacy or a base face or Boss power cap is not going to help you out. How many volts is your live in the UK? 240. 240 volts AC. I ran several amps with the same ground and live without issue. Yeah, that's fine. Okay. Yeah, so anyway, this is Adam's stank ass thing, amplifier. As you can see, it's been on fire, and therefore it's no longer functional. So we've got to find out where the issue is. It's a little bit foggy in there because, you know, it's that time of year. So we're going to have to probe around and try and feel our way around a little bit in here. Okay. So, first things we do is we check to see if there are any shorted MOSFETs. The first thing we do before applying any sort of power is, do we have a short circuit across the power terminals? No, we do not. Okay, so the power supply is fine. If the power supply was shorted out, then we would have continuity between these two. Now, in these boards, this is the same circuit design as base phase DB1.3. It's the same circuit design as in that other loudness.com we just fixed. Audio pipe, fucking SPL Dynamics, Vibe, they all use the same circuit because it's, you know, it's cheap to make and it does power. Next thing we need to check is, do we have any continuity, any short circuits between any of the output FETs? So the output FETs are going to be these ones here. So let's check between one. Okay, so we have 22 ohms between these two. So there is a short circuit across the output section here. And how about on the other side? Okay, we have, yes, the short that we're looking for is generally between legs 1 and 3. Okay, so we've got 14 ohms between that one, so we're going to do this. 14 ohms between 1 and 3 there. 34, 34, 34. So these three that are reading 34 are probably fine, and the dead one is probably this one that's reading 14, because we'll just be reading the short of that one through the gate resistors. On the other side we had 22, didn't we, across there, but we didn't have any. So the other side, there's no continuity or shorts between the gates. There's only continuity and shorts of 22 ohms between the, what is it, yes, the gate and the drain. So yeah, we have output section failures to look for. So in these amplifiers, it's a really simple repair most of the time. You can usually get away with just replacing all 8 output FETs, and if the amplifier's gone down in a more serious way, then you only have to replace the 8 output FETs and the driver transistors 1, 2, 3, 2T, 2X, 2X, and where are they on this side? I think there's 1, 2, 3. 2T, 2T, 2X. Oh, the shape is different around this side. Yeah, it's probably these 3 down here. It could also be these 3. These 4. Let's have a look. 1, 2, 3. I can work it out by looking at continuity between the gate and these ones. But yeah, essentially, you can get away with just replacing all 8 output FETs and then 6 drive transistors. And 99% of the time, you have a functional amplifier. So, because I'm lazy, let's remove this header, so I don't have to remove the whole board out of this. I can just remove the main board, not the preamp board. There we go. Yeah, literally hundreds and hundreds of brands use this board design in their amplifiers. So many. I've actually done a very detailed repair video of this amplifier board on my channel. I think it's called Generic 2000 Watt RMS Amplifier Repair Log or something like that. And it actually uses a base phase DB1.3, which is the same circuit as this, just a tiny bit bigger, but it's the same circuit. Ah, look, decent build quality. We have screws down the middle of the amplifier to the heatsink. Nice, I like to see that. That's a good sign. Not a bad job, loudness.com. We also have a header over here, an unused header, which would be for some fans or some LEDs. So we could actually put some LEDs in this if we wanted to. Not that you'd be able to see them, but yeah, fuck it, pretty cool. Board design doesn't mean it uses the same components though, right? Yes, it does, Adam. Yep. Pretty much, these amplifiers all use the same fucking components as each other. It's the same. There's only a very select number of factories that are making car amplifiers. So unless your company has employed a amplifier design technician like Alpine, JBL, Focal, fucking what's the others? Hertz actually are pretty shit. They use so yeah, Alpine, JBL, JL Audio, Rockford Fosgate, Focal, Audio System, Gladen, Moscone. Any amplifier brand that has their own amplifiers that they have employed an amplifier design technician to design them a circuit from scratch, that is the good shit. They are proper unique amplifiers that are just unique to that brand. All the other shit, all the other brands that you see, it's all just the same amplifier with a different sticker on it. And that goes for Sundown, DC Audio, Digital Designs, SPL Lab, Ground Zero, all Vibe, every single other amplifier that you have will be the same as another brand has, the same board, the same components, the same everything else, maybe a little bit of different build quality, maybe a slightly thicker PCB, or maybe like slightly different output FETs, but nothing that's going to make a ginormous difference to the output. It's all the same shit. It's the same fucking shit, and people pay up front for the same shit. That's why I have so much respect for brands like JBL and Alpine, JL Audio and Rockford Fosgate and shit like that, who actually have spent the money to employ a dedicated amplifier design technician to make them something from scratch. And that's why you'll find that those brands tend to be more expensive. JL Audio, for example, is very expensive, but you are getting a completely unique amplifier. The brand that I have the fucking most respect for is JBL, because not only do they make their own amplifiers, the amplifiers are absolutely superb, and they don't charge a fortune for them. They're very cheap. Alpine also don't really charge the earth for their amplifiers, but they are very, very good design. I would much rather be using an Alpine MRP 2000 watt than I would a Sundown SCV 2000 watt. I would much rather be using the Alpine. Okay, here we go, son. Baby little thing. So, first things first, I'm the relax. Let's remove all the output FETs. Now, the output FETs this is using are good old standard bog run-of-the-mill 640Ns. So, we'll remove all the 640Ns and start from there. Hello, do you know the output IC number of Ground Zero 4K? Yes, oh shit, how the... Zuxiang? Sorry if I pronounced your name wrong, buddy. So, sorry, do you mean the chip, like the actual driver chip, or do you mean the output MOSFET? Which part do you need the number of, my friend? I know both of them, but I just want to make sure that I'm giving you the right information. Okay, that's the 4 from one side removed. The build quality of this is actually not bad. The PCB is relatively thick. The solder connections seem pretty nice. It doesn't look like they've used lead-free solder. It seems that they've actually used some leaded solder. You can tell when you remove these things what the solder quality is like. It seems to be pretty decent. There's relatively good grounding traces on the back. Yeah, it's got screws to them down the middle of the board to the heatsink as well. Yeah, it doesn't seem too bad at all. This is probably on par with or slightly better build quality than a Baseface DB1.3. Okay, so that's all the Standcast output FETs removed. So, let us see, just out of pure interest, how many of those output FETs were actually dead. So all of them read as partly shorted in the board, but I know from experience of these amps, the protection circuits are very fast, and so it usually only kills 1 or 2 FETs, maybe a handful of FETs. So let's see. Okay, so that one's not shorted, so that's probably fine. And usually these FETs, if they die, they short. If they're not short, then they're generally okay. That one's probably okay. That one's definitely shorted. That one's probably okay. That one's probably okay. Probably okay. Probably okay. Shorted. So, it seems that we perhaps only lost 2 FETs in that. So we can double check and confirm the health status of the rest of the FETs by running them through my transistor tester here, which will tell me all the characteristics, the turn on voltage, the RDS, etc. So, we are looking for a VT, which is a turn on voltage of 4 volts, and an RDS, a resistance of 0.5 ohms. So let's make sure that these are all the same. So we have 4 volts and 0.5 ohms. There can be a little bit of deviance just from, you know, testing every time I take it out and put it in. But that one's absolutely identical, so that's good. .2 and 0.7. So that's a little bit higher VT, so it will turn on slightly later than the others. Let's do one more test. Slightly higher RDS as well. Okay, so the RDS has gone back down. So the VT is a tiny bit higher on this one. So if I was choosing out of all of these which ones to use, I might not use that one, just because it turns on 0.2 of a volt later than these first two. Perfect. VT of 4. 3.9, that's close enough. .9, again, close enough. So, let's have a look. So we've got a nice little batch of 5 FETs here, which all read absolutely identical. So I can take 4 of these and load these up into the amplifier on one side, and then choose some others from my batch of FETs on my table here to replace the other side. Now, this singular one here, out of pure interest, that read as VT of 4.2, whereas these were VT of 4. Why was that one different? Did it get damaged when the amplifier blew, or is there some other reason? I'm going to let you decide that one by taking you into the zoom in of this, and this is again going to show you how important it is to do what I say in regards to this. So that one was actually 3.9, so that was a 3.9, and these ones were all, so these were all 4. That was a 3.9 and that was a 4.2. So let's take my zoom in camera here and show you why it's very important. So the 4 identical ones were all from batch 129P6K. So these were all the exact same batch in the factory when they were produced. The one that reads 4.2 that turns on later is 129PJF as opposed to 6K. So this is actually a different batch of MOSFET, and having this running in parallel with the others, this one, because it turns on only 0.2 of a volt later, does make a difference, and the output section will be less efficient as a result. It'll get a little bit warmer than, you know, if it was the same batch. So we don't want to use that one. This one, again, is a 129JFQZ, so that's the same as that one. And these 4 are all the same. So we want to make sure we use the same identical batch, because that means the best efficiency and the lowest chance of the amplifier failing. So, let's put these ones away. These 2 dead ones can go in the sandcastle. Now let's take 4 replacement FETs, and because we're doing this for my good friend Adam Francis, we're going to do this very cheap for him, so I'm not going to use any brand new FETs. We're going to take some from a donor amplifier. These are all my donor 640N FETs. So we're going to take some from here, so that it makes it very cheap for Mr. Francis, because we haven't had to buy these, they've come from donor amplifiers. So I just need to find a batch from this pile that also has a VT of 4.0 and RDS of around 0.5 ohms. And we need to find 4 matching ones, and we'll be good to go. Now actually finding 4 matching FETs in this pile does take a little longer than perhaps would be ideal, but I'm sure if I remember correctly there was 4 nice matching ones somewhere around here. Yeah, this does take a little while actually, finding 4 matching FETs. 269p. It would probably actually just be easier to get 4 brand new ones rather than scrounging through these. I think these FETs are only like 30p each anyway, so it'd be like less than £1, but just thought might as well. Okay, if I don't find 4 matching ones in the next minute or so, I'm just gonna put new ones. Alright, there's a matching pair, there's a matching pair. Right, almost there. We need to find 1 more. We would find 1 more from that batch, and then we have 4 matching ones. Oh wait, no, we have another batch over here, which we might end up with 4 from. 320K. Aha. Here we go. IRF 640. Ah, shit. These are 640s, not 640Ns. They're rare. They're pretty good. Okay, I can't use those. They're not 640Ns. They're actually just 640s. It's pretty rare. Okay. They're slightly different FET, so I can't use those in this amp, but... Okay, here we go. I found 4 matching ones. So we have 3.9 volts on the VT. That's acceptable to use in parallel with these ones. 4, that's bang on. 4, that's bang on as well. Sweet, I think this is going to be perfect. Four, yeah, absolutely perfect. So this little bank of 4 FETs that I found that were taken from a section of an amplifier that didn't blow. Not only do they all read exactly perfect with one another, but they also read identical to the 4 original FETs that survived from this amplifier. Now, if you think about it, using 4 FETs from a donor amplifier from a area that didn't blow is exactly the same as using 4 of the original FETs from this amplifier from an area that didn't blow. It's exactly the same. Because both of these batches of FETs have been used before and weren't damaged in whatever caused the amplifier to go down. So it's the same. If I was doing this repair for a, you know, like a regular paying customer that was paying me my normal prices and all this jazz, and you know I wasn't good friends with, then I would just use, I'd replace all 8 with brand new FETs and charge accordingly. Whereas in this case, reusing the 4 from the amplifier originally and using 4 that I took from donors basically means this amplifier costs what, like an hour of my time? Like nothing really. It hasn't cost me anything in parts, so it's only cost me a little bit of time. Any tips, quick tips for a JBL car amp that have 2 front channels and 2 rear channels, and the 2 rear channels simply don't play, and the 2 front channels play just fine? That'll probably be a Class AB amplifier. So take the back off the amplifier, power it up, and make sure that you have the rail voltages for the rear channels present on the transistors. If you do, then make sure that the audio signal is reaching the drive circuit of the rear channels. If it's not reaching the drive circuit, then there's probably like a broken connection on the RCA inputs for the rear channels, or it could be a dead component in the input section, in the preamplifier section. If the if the audio signal is getting to the drive circuit of the rear channels, make sure that it is on the output transistors of the rear channels. If the audio signal is on the output transistors of the rear channels, but not on the speaker terminals, then you have a break along that line from the outputs to the speaker terminals. So you need to check that. By the sounds of it, the amplifier is still working fine. I mean, it's not got a short circuit anywhere, because if it had a short circuit, then it would be in protection, or the power supply would have blown. So the rear channels I don't think have been blown and are damaged like so. It sounds like you've just got a broken connection somewhere, otherwise the amplifier would be in protection or something. And just for the record, I've used these donor parts in loads of amplifiers over the last 1.5 years of doing amplifier repair, in my own amplifiers, in friends' amplifiers, and they continue to work to this day. They're brilliant. Like a MOSFET generally, if it dies, it dies. If it doesn't die, it's no different to how it was when it was new, really. I mean, semiconductor parts do deteriorate over time, but it's so slow. These amplifiers are so young anyway that there's not much difference between a MOSFET that's been used in an amplifier for like a couple of years, really, compared to a brand new one. There's not going to be any real electrical differences. So it doesn't really make a difference at all. How far did you get on the US amps? I haven't got far on that. I'm not going to get far on that. It's too much of a headache to repair. I don't even want to take it out of the heatsink. Honestly, I really do not want to repair that thing, so I probably won't. I've already done an attempted repair, like on it, like a top board repair with it in the heatsink. But I really don't want to have to take that thing. My workbench is not long enough. I can't physically repair it because it doesn't fit on my workbench. So I need to redo my workshop in order to repair the thing. Alright, so now for an interesting part. So we've found 8 FETs that will work in this amplifier. We've removed and desoldered all of the original FET pad locations. So now what we need to do is we need to put some power into the amplifier, and we need to have a look and see what the drive waves look like on the output section. Because before we put the FETs in, we need to make sure the drive circuit is working correctly. If it is not working correctly, then we need to replace the 2T and 2X drive transistors. If it is working correctly, then we can just go straight ahead and fit the FETs, and it should be done. This is the place where all the junkies go, where time gets fast but everything gets slow. Can I get some gasoline? Step into a modern scene. Take a chance I'll never see to be the making of a dream. I don't wanna take it up a little Joe. I don't wanna say it, but I gotta know. This is my calling. I said, darling, chuck it, darling, all I can do to you. Good tweeter location. I have a Volvo 240 and I have 2 bullet tweeters on the front of the instrument panel near the windscreen, facing flat up to the windscreen. Yeesh, that's going to give some interesting reflections off of the glass. I would say like the best tweeter location is at ear level, left and right on the A pillars, like bush, ear level, A pillar, time alignment to throw that one back in time to bring you in the middle of the two. If you must have them firing at the windscreen, you're going to get some reflections, but you know, you might not notice the difference. It might be fine. Okay, 10 volts going in, so let's have a look. Let's see if the drive circuit survived it or no. I'm going to make my scope view a little bit bigger here so you can see that a bit easier. So in order to check the drive circuit, we want to probe the gates. The gate pads of these, so that'll be pad number 1 in this case. So we have a low side and a high side. So first of all, I'm just going to make sure the power supply section works. Let's turn probe 2 off. My oscilloscope is 4-channel, which comes in very handy to check multiple various things. So let's give this thing some power and see. Oops, helps if I actually let the thing pass some current. Also helps if I turn my scope to the correct setting to view the wave correctly. Okay, so as you can see, we're drawing 0.3 of an amp, which is very, very good. We have a superb looking power supply drive wave. Looks very nice indeed. Now, let's just check that we have the rail voltages that we need. We have 36.85 volts on the positive rail, and on the negative rail we have negative 36.29. Okay, that's fine. So let's check the low side drive. Do we have a square wave present? So there's no square wave present on the low side drive. However, that is usually the case because often these amplifier circuits, they need some kind of RCA input signal in order to force the low side drive to oscillate, because this is a self-oscillating amplifier, which means that it won't oscillate the Class D output section without either feedback from the FETs in place or without signal from an RCA. So if I plug the amplifier's preamp board in here, take my wire here from my frequency generator, and we're going to shove 44 Hertz into the amplifier. Let's put the input in here and make sure the gain is turned down nice and low, because I don't want to clip the preamps board. Okay, yep, low pass down, up a little bit, subsonic, bass boost off, yep, okay. So let's turn it on again and let's see if we have any waves on the low side drive. See, one difference about this amplifier, hang on a minute. The low side rail disappeared. That's interesting. I reckon we might have a shorted transistor on the low side drive section, because, and the reason I say that is because these amps don't have any pull down resistors, which means that the rail voltage stays where it is when you turn the amplifier off, but the low side voltage rail actually disappeared, which might mean that it's leaking through somewhere, but it might not. But that's just a little theory that I have for at this point in time. So let's power up again and let's see if we are presented with any drive waves. .44 Hertz is going in, and I don't see any drive waves anywhere. Aha! And we also have some voltage where there shouldn't be voltage. We have some voltage where there should not be voltage. Okay, so this is very interesting, and this is something to take note of. I'm going to take this amplifier back out of the thing. So this is how to check whether your drive circuit is intact or whether it is actually faulty. Put that down to the side again. So this amplifier is a Class D amplifier. So on every Class D amplifier you have a high side of MOSFETs and a low side of MOSFETs. On the high side of MOSFETs you should only have positive rail on pad number 2 or pin number 2 of the MOSFET. So on this amplifier, oh, hang on a minute, maybe I just have a solder bridge. Maybe I just have a solder bridge. I think that could have just been a solder bridge actually. Let's actually try that again. Now that I've removed the solder bridges that I just created, let's try that again. Aha! Okay. Okay, my bad. Teaching myself my own lesson. Check for solder bridges. Whenever you finish soldering, check for solder bridges. So what happened there was after I finished desoldering, removing the solder from these holes, there was actually a teeny tiny solder bridge between the high voltage rail and the gate of one of these FET pads, and I didn't spot it, and so it looked like that there was an issue with the drive. However, upon removing said solder bridges, we now have good drive waves on the output section. So this output section does actually present a drive wave to the high side FET as well. So if we apply the power again, you can see what I mean. The high side, we should have high voltage rail as we do on pad number 2. And on the low side, we have low voltage rail on pad number 1 and pad number 3. Now because the amplifier is working correctly, you can see here that we have a square wave riding along the low side drive, which is there, as you can see on the screen. And that should be present and equal and identical on all 4 output section pads, which it is. And because this amplifier circuit is designed like so, we also have the same drive wave frequency riding along the high side drive around 0 volts, around ground. So that looks good to me. As a result, we are perfectly safe to go ahead and fit some new output devices, some new output FETs. So these 8 output FETs that I have ready here are good to go in. Because this amplifier has no pull down resistors, I need to manually short out the rectifiers to remove the voltage from the rail caps. Like so. Do you know the output number for the ground zero? Yes, Zhuang, I answered your question before, kind of, and I asked you, what do you mean? So this guy here, this comment here, Zhuang, I don't know how to say your name. Do you mean the driver IC chip, or do you mean the output MOSFET? What do you mean? The output IC number of ground zero. If you mean the chip, then I know the answer. And so let me know, do you mean the chip? And I'll tell you what the code is. Okay, cool. Yeah, so that should have removed all the rail voltage from our amplifier. So we have nothing now sitting on the outputs here, nothing on the low side. So let's go ahead and fit these FETs and see it do some power. Zhuang says yes, the chip. Okay, Zhuang, I'm going to put the model number of the chip that you need in the live chat. So the original chip that comes with that amplifier is an IRS 21844S. That's the original chip. So I'm going to put original. But there is a better replacement that you can use. I will tell you the better replacement. It is a Fairchild part. And it is, I'll find my little notes on it. Part number. The better part to use is actually an FAN 7393A. So if you replace the original chip on the driver board with an FAN 7393A, should be good. And you can thank H1 Nicholas for discovering that, because he discovered that part. So, what does everybody think Adam's Stankass Loudest.com is going to bench? How much power do you think this thing's going to do? And Adam, what do you think this is going to do, my friend? If Adam is still watching, of course. Why the fuck's my showing fucking fucking? I whistle all day long, trust me, man. I'm always flipping whistling. People are always picking me up on it. I do it without even thinking. It's just completely automated now. Okay, so we got a few guesses. The amp is rated at 1000 watts RMS at 1 ohm. And that's a 14.4 volt rating as well. Oh shit, we have 2 Seths in the live chat now. Haha. Crazy. So we've got 850 at 12.3, 987. So guys, to make it easier, just guess 14.4 volt ratings. I mean, you can guess. I guess you can guess a 12 volt rating as well. I think this is probably going to do about 720 watts at 12 volts, and just shy of a K at 14.4 maybe. Be nice if it does over 1000. That'd be pretty cool. Don't know if it will though. We'll have to find out. Okay, cool. So the FETs are fitted. So this is the moment of truth, in a sense, as to whether the thing actually comes on and does the Class D switchy thing that it should do. Okay, power time. Music. So the low side was this one. So therefore, if I probe the case of these FETs, this low side, then this should just come to life. Yay! So it's drawing 0.6 amps. We have a blue light. Uh-oh. I'm wondering whether it needs more than 9.8 volts. Let's give it a bit more. Or maybe I need to trim these. Hang on, let's have a look. No, you shouldn't need to trim those. It's miles away from that. Okay, seems to be going in and out to protect. It's trying to build the driveway, but it's just going into protect again. It was working just a second ago, though. Interesting. So we've got some DC. Oh, so it's losing the low rail. It's losing the low rail. Why is it losing the low rail? I wonder if it works outside of the heatsink. That's weird. Yeah, there's DC on the speaker outputs. So it's either the FETs or the drivers. So I might try putting just 8 brand new FETs in, or I might try just changing the drivers out. I mean, it worked for a few seconds, didn't it? Then. Nothing seems to be getting hot. It's just drawing some excessive current. That's all. Or maybe it's the output inductor. Yeah, so there's some DC on the speaker terminal, which is causing it to go into protection. It worked for a few seconds though, which is weird. But the reason that it's failing is it's losing the low side rail. So the low voltage rail is getting eaten up by something. It's getting shorted out to ground. See that? Interesting, okay. Nothing's getting hot. Okay, I guess the FETs are coming back out again. Whoops. See, if it was a solder bridge, then it would have done it straight away. Whereas it didn't do it straight away. It actually worked for a few seconds. Then it kind of just started jittering out. You don't usually get solder bridges once you've finished soldering the FETs in last. Usually the solder bridges come when you're desoldering, so... okay. I'm wondering if this capacitor actually looks like it's slightly bulged. Alright, let's do a proper repair on this and let's fit all brand new FETs. Ooh. How is there still some voltage left on that? Oh, I powered up again, didn't I, before I turned it off. Ouch. That was not good. Hot solder on the fucking hand. Alright, let's power it up now. Now all the FETs are removed, let's power it up. Let's just check the drive waves are the same as they were before. That's weird. Okay, we've got 0.3 amps, 29.89. Hang on a minute. Wait. Ooh. When I flex the board or push on the board, the health of the... Something changes. What's causing that? Hey, Marilyn's joined on. This is really weird. What? When I bend the board, something changes. So there's something that's obviously slightly disconnected from the board, or some bad solder connection or something. When I flex the board, I get a change in the drive wave health status. Seems to be potentially to do with the inductor. Huh. Okay. What I'm going to do is I'm going to short out these rails. I'm going to load up a couple of FETs. I'm going to have a play around with it, with the board flexing. Okay, so I've got 2 brand new FETs. Now, I'm not going to load all 4 up because we only need 1 FET per bank to test this. So I'm going to use 1, and that helps save any issues. So I'm going to use 1 FET per bank. I'm going to try and power it up again. I'm going to flex the board a little bit and see what the thing is that it's doing or not doing. So low side drive is this side. So, okay, let's do some power. So look at that. Okay, so there it is working again. Ah, look, yes, if I flex the board, it stops wanting to work. I think it's a shorted inductor. Look at this. If I hold the inductor in a certain place, it works. If I then move the inductor, or if I let go of it, it stops working. Now we can prove that. We can prove our theory by probing the low side drive output, which is what's connected to the inductor, and also probing the speaker terminal, because the speaker terminal shouldn't have any switching waves present on the output terminal. If the output terminal has some switching waves present, then it means that they're passing through the inductor and not getting filtered out. And the only reason they wouldn't be getting filtered out is if the inductor was shorted. So let's see. Yes, it does have some switching on it. Right, there my friends, then is our issue. This inductor appears to have a small short on it somewhere. So we need to pull the inductor. Aha, look, I can see it. I can actually even bloody well see it. Look, right, here we go. Here's a lesson time. We're going to learn. We're going to learn today. Actually, fuck that. I'm going to use this. Come on, focus. Okay, there we go. So, you can see here that the inductor has some kind of dust on this leg here, and that is because it is shorted and rubbed away the insulation, and there is a short circuit between this, and that is what is causing the amplifier to go in and out of protection and fail like this. So what we need to do is we need to remove the inductor, isolate that short, and put it back together again. Whoa. Adam, I hope you're watching this. This has taken me quite a while, considering the small size of this amplifier. Shorted inductor is not the most simple of repair jobs. In answer to Nick Sutton's question, check for a bad TL-1021. You need to make sure that you have good looking square waves on pins 9 and pins 10. You should also have a good sawtooth wave on pin 5, and you should also have a good 5 volt regulated voltage on pin number 14 or 13 or 14, I think it is. That was quite sudden. Quite a sudden release. Okay, so Mr. Inductor is finally off the board. And as we can see here, if I try and zoom in so you guys can see. Will it focus this close? It should do, surely. There we go. So yeah, as you can quite clearly see, this inductor has a shorted lead just here. So if I pull this back, you can see there that it's rubbed away all the insulation on the wire. Excuse my filthy nails from the workshop. So that will have been shorting out on this area here on the top. So it's just here. And you can see that the bare copper is exposed. So therefore we need to isolate that and reassemble. Oh yeah, just bend that back round. I think that's the only area on here that is actually shorted. Sometimes they can have multiple shorts, but I think this is the only place. So yeah, in order to isolate that, all we need to do is use a tiny bit of tester tape. Excuse me. Tessa tape. T-E-S-A. Tessa. It's no, it's not electrical tape. It's like fabric tape. Yeah, this tape is absolutely fantastic. I use it for all sorts of things. It's bloody brilliant. It's so useful. It's the sort of tape that they use when they insulating wires in like factory car wiring looms and things like that. Is beautiful, fantastic tape. Really, really useful. Very sticky, very insulaty. Superb kit. Superb bit of tape. Okay, cool. So this should just work now. Now that we've isolated the short circuit on there, this should just work. There we go. Nice big switching wave. And it's not being affected by me touching the inductor really. It's changing in frequency a little bit, but yeah, good. Nice, yeah, that's good. That's a good job. Okay, wicked. So that's all it was then. It was a shorted inductor that caused the amplifier to fail. So what I've got to do now is put the FETs back in and we can bench test it. So Adam, are you still here? Who's still here who's interested in seeing what power this bench tests? Nick Sutton. So if you saw no square waves, then the reason for that is probably because you have voltage on pin 3. So check what voltage you have on pin number 3. If you have anything more than 0.1 volt on pin 3, if you have like 3 volts or 5 volts on pin 3, then the reason you haven't got any square waves is because the TL-1021 is in protection mode, and it's being sent into protection mode by some problem on the circuit board. So if the TL-1021 is in protection mode, it's because there's some other problem somewhere on the circuit board. So you've got to find the problem that stops the 494 from working. I'm being a good boy and going through and checking all my solder bridges this time. Hey, where's the donate button or whatever around here to send you drinks money? Ah, thank you, Tom. Is it strictly Patreon? I have a little $ button here, but it just activates Super Chat. Yeah, Super Chat is the donation thing. So if you want to donate on my live stream, then massive appreciation, man. Thank you very much indeed if you are considering doing that. You can either donate on the Super Chat, or you can donate on the Patreon, but I think that's a monthly thing. Or you can just shoot me a quick donation over to my PayPal if you are that way inclined. Yeah, massively appreciated, but I don't expect donations at all. But if you feel like you want to shoot me a little drink money or something, then thank you very much. And yeah, those are the options that I think are probably best. What the hell? I had 8 FETs, now I have 7. Where's the other FET gone? No, come on, man. Oh, wait. Oh, wait, here it is. I think this is it. Yeah, here it is. Man. Huh? Don't do what? What'd you say? Okay, FETs are back in, and this should just work now because we sorted out the shorted inductor, sorted out the shorted FETs, so this should just straight up work. My girlfriend says your voice is relaxing and helps her sleep whenever I'm watching. Oh, that's adorable. I'm glad. I mean, I don't personally, like, I wouldn't personally rate my voice on the kind of my voice on the relaxing scale, but no, that's pretty cool. Thank you for letting me know that. That makes me feel cool. I have 13 minutes till I got to sleep, but I need to know. R100, where are you from? Sam, have you ever seen a Stark bomb in person? Harry Richmond, I own a Stark bomb. I have a Stark bomb down here in the workshop, and I've had one for about a year now. Yeah, I've got one. He gave me one. Well, I bought one from him for a very cheap price. Yeah. Okay. So yeah, Adam, if you can hold on until we bench test this, then that'll be good. Last little test before we turn it on, put it back in the heatsink, and do the bench test. Last little check. Actually, you can see my scope up here anyway now, so. 0.5 amps. Yeah, looking great to me. Sweet success. Awesome. Okay, back in the case she goes. And bench test time. Australia. Cool. I personally am yet to visit Australia. I really, it's on my bucket list. I'd love to do it. I'd love to visit Australia. How many amps have you repaired today? Well, today's been a bit of an interesting one because most of the amplifiers that I've picked out for repair have needed some parts that I haven't got in stock. So I've made quite a few orders for some bits and pieces. Yeah, hopefully the amps that I started on earlier today, we can continue and finish and make a successful repair when the parts come. But I think we've repaired probably 3 that I know of that I know of as repaired. The others are probably repaired once we get the replacement parts in stock. Nick Sutton says 4.7 volts pin 3. Yes, well there you go, my friend. That is your problem. You need to find out why you have that voltage on that pin, because that shouldn't be there. The reason that you have voltage on pin 3 is because pin 1 or pin 16 is higher or lower than pin 2 or pin 15. I can't remember which way around it is, but basically, Nick Sutton, you need to read up on how the TL-1021 works and how error amplifiers work. So pins 1 to 15 and 16 are inputs to error amplifiers. Pin 3 is the output of those combined error amplifiers. So yeah, basically there's a problem causing there to be voltage that shouldn't be there on pin 1 to 15 or 16, and as a result pin 3 is the kind of detector that goes high when it detects there's a problem. What you can do is you can temporarily ground pin 3, and that will disable the protection, and you can power the amplifier up if you are that way inclined. If you're, if you know what you're doing, you can power the amplifier up with the protection disabled and see what gets hot or see what explodes or whatever. Voltage is on pin 2 only, so you only have voltage on pin 2. So you got 0 on 1, 0 on 15 and 0 on 16. Is that what you're telling me? Yeah, we're almost there, guys. We're nearly benching this one. I've just got to put all the clamps back on for the MOSFETs. because otherwise they'll get hot and explode. Don't want that now, do we? No, no, we don't. Voltage is only on pin 2. Well, if voltage is only on pin 2, then that suggests that perhaps the... well, that's really unusual. That's very unusual. I think if you've only got voltage on pin 2, then you're missing some voltage on pin 1. I think there should be some voltage on pin 1 that's missing. So try grounding pin 2. Well, no, hang on a minute. What's it called? Nick Sutton. Make sure that all of your MOSFETs are not in the amplifier, especially the output MOSFETs. Make sure you're using a very low current power supply, like 2 to 4 amps, and ideally 9 or 10 volts if you can. Ground pin 2, and the thing should come to life. And when it comes to life, you can then do some more investigations to find out what's causing the voltage to be present on pin 2 if it shouldn't be there. Alright, one last little test before we power up on the big supplies. Just to make sure there's nothing shorted to heatsink case or anything like that. There we go. Boom! Straight away comes to life. Low current draw. Excellent. Excelente. So let's plug her into the big supplies, and this is now finally what you guys have all been waiting for, the bench test. Have you ever worked on SCAR amps? No, somebody asks me this every single live stream. We don't get SCAR in the UK, so therefore I've never worked on one, sadly. But SCAR amps are generic circuit designs, so I have worked on amplifiers that are exactly the same as SCAR amplifiers, just not with a SCAR badge on the front. So the likes of Ground Zero, Hyphonics, DC, Sundown, etc. will be the same circuit designs as SCAR, just with a different badge. Okay, let's clean this up a little bit. Now we don't need our, actually, can we fit it? I was going to say, can we fit our 70mm cable in here? It's a bit tight. We don't technically need it. We could just run our 4 gauge. But if it fits, then I sit. If it fits, then I'll put it in. I think it fits just about. Yeah, just about fits. Okay, cool. Sam, did you ever pick up that tweezer you used to glue my sub off your driveway wall? Probably not. No, it's probably still there. Nope, I'm going to use the 4 gauge. They're too close together. They're going to touch. Full gauge it is. All outputs removed and voltage still present even without remote. Yeah, it will be. The rail voltage will be present there because it's stored in the rail capacitors. Oh, you mean the voltage is still there on pin 2 without the remote? That's strange. You know, it's funny, I get a lot of questions where people are stuck because their TL-1021 is in protection mode with the voltage on the error amplifiers. It shouldn't be there, but I never run into that problem. I don't understand how so many people have amplifiers that have something throwing the 494 into protection. Like, I really rarely ever get that in the workshop. You remove all the dead parts, all the dead outputs. You remove all the dead outputs, you remove all the dead power supply FETs, you remove all the dead drivers, and the TL-494 is just like, hi, working fine, y'all, what's going on? It's like, okay. One of the reasons the TL-494 will be in protection mode is if you have DC on the speaker terminals. So check that you haven't got any DC voltage on the speaker terminals. If you have, then the TL-494 will probably be in protection mode because of that. Okay, that's all the dummy loads fitted. 1 ohm, yep, this is a 1 ohm amplifier. So let's get my 45 hertz test tone stanking up in here. And let's turn the gain down a tad. Gain, low pass filter, yep. Okie dokie. Let's get my power supplies, remote turn on voltage hooked up. Okay. Moment of truth then. Adam, you watching, buddy? Are you watching, Adam? And in the words of the hydraulic press channel, and here we go. Yeesh. Okay, so that clip point is a very low percent THD. This doesn't look like much power, but that's a very low percent. That's like a little bit more than 1% THD, perhaps. So let's see. 1 ohm, and we had 22.89 volts. So at 12 volts it made 523.9 watts RMS. So what did that do at 14.4? $760.8 watts RMS at 1 ohm. Okay, that's a little disappointing. Let's see whether we can push it into a little bit of soft clip and see how much clip do we need. How much clip do we need in order to get 1,000 watts out of this? Okay, let's try that. Actually, I'm going to zoom out a little bit on the scope so we can see a little bit clearer on the wave. .3. I think that's about the same, isn't it? Oops. How was that less? How did that do less power? What? Right, well, with a wave that looks like this, it does 873 watts. So, not great, then. Not that great. This amplifier is actually, the circuit is equivalent to the base phase DB1.2, so that actually makes perfect sense. Yeah, it does the same power. Yeah, the amp's rated at 1000 watt RMS at 1 ohm. It's not doing that any day of the week. So should we see if we can get it to do 1000 watts? I see, the thing is, I don't want to blow it again. So I could keep going into clip and see whether it does 1000 watts. We could either do that, or I could do a 0.5 ohm test. We could test it at 0.5 and see how much power it does. So yeah, basically it's a base phase DB 1.2, and that you could sell this in the UK for about 80 quid to the right buyer. If I sell it, if I list it and I sell it and I explain it's the same as a base phase DB 1.3 with a different badge, you might get 80 quid for it. Nah, there's nothing wrong with the amplifier at all. Yeah, the amplifier's working just fine. I know this circuit very well. It's the same as a base phase DB 1.2, and they do only put out about 750 or 800 watts on their best day. Alright, well there we go then. That's that. They say you can't polish a turd, but I'm pretty sure I'm doing that just now. Right, yes, good night, Mr. Francis. Everyone say good night to Adam. Good night, Adam. Night, night. Right, so that's that. Next amplifier then. Ugh. Okay, now this next one is also a piece of shit. This is a Hyphonics. This is a 3.2K apparently. It's rated for 3.2K. Doesn't quite do 3.2K. Tom says, won't buy a full drink but have a tip. Thank you, Tom. Cheers for the $2, man. Massively appreciated, dude. Many thanks. That makes it all the worthwhile. Just little things here and there makes it all more worthwhile. So yeah, this thing. Now I don't, because I'm very thorough with my repairs. I generally don't get things come back, or if they do, it's because the customer's blown it. It's their own fault. But this one I've repaired before, and so I repaired it, I got it back, I found something, sent it back, and so this is the second time that it's come back. And it's not blowing any FETs. This is a really weird one. And it appears to be killing the KA7812 voltage regulator on the output section. And I'm not too sure why. So when I first repaired it, it needed the 7812 replacing. And it needed the power supply replacing, needed the output section replacing, it needed everything. So I basically rebuilt this from the ground up. And I repaired it, I did a bench test, did a 45 minutes endurance test. All was good. Sent it to a customer. It worked for a couple of days. And then it stopped working, but it didn't blow. It wasn't in protection mode. There was just no sound. It had a blue light, but no sound. I was like, okay, check all your wiring. And so he checked it all, couldn't find the problem, so he sent it back to me. And then I had a look, and I found that the 7812 was dead. And I was like, that's really weird. Nothing else was dead. Like, the outputs were fine, the driver ICs were fine. There was nothing else wrong with it. So then I was like, well, that's weird. So I thought maybe that's just a one-off weird thing with a bad voltage regulator. So I replaced the voltage regulator. I also replaced the smoothing capacitors around the voltage regulator to make sure it wasn't those. And I checked the rectifiers, and they all seemed fine. So again, I ran it for a bench test, and I ran a 45-minute endurance test, and it was fine. So I sent it back, and the same thing happened. Customer a few days later said, oh yeah, same thing's happened, it was working fine and it's just stopped playing music. So I'm like, what the fuck? So now I'm going to be really scratching my head and really diving deep into this and trying to figure out what the fucking hell is going on with it and why it keeps killing the 7812. Because it's very, very, very confusing. Okay, power supply is fine. Output section also fine. So let's check that dodgy KA7812 that seems to be dying. Let's check that and see whether it's died again. So this died once before for apparently no reason after I bench tested it and endurance tested it. So the KA7812 is just here. So is it dead again? Yeah, it is. Yeah. The 7812 has killed itself again. 1 sec, I'm just getting a phone call. Just bear with me for a moment, guys. Thank you. In relation to the phone call I just had. So thank you very much for sticking in with the live stream. This is going to be a really interesting repair because I don't understand why it is killing the 7812 all the time. So I would like to find that out with you guys because that could be something very useful to look for in the future.